You use it over. Same thing. Copper will build up, and you'll be able to track it on a test kit if you wish. And if it doesn't build up, or if you keep using it, you start to get the thing about the green hair, the bluish fingernail. Anyone who has a high level of copper in the water needs to run a chlorine level as low as possible. And that's the essence of like the pristine blue and some of the other copper-based systems. The old copper-silver ionizers, they actually impart spit copper ions, and some of the crummy ones have caused a great buildup of the copper. The only way out of that really is to drain. Now, there is a drinking water standard on copper, and most of us have this Bible called the Handbook of Chlorination at big companies. And it's like a $280 text now. When I bought my first one, it was only $100. But in the back, there's a drinking water standard. 1.4 ppm of copper is your drinking water limit in this country. So it's okay, actually. But that becomes useful. If you have a pool with higher copper than that, you could easily say something, you've exceeded the drinking water standard, and use that as a way of explaining that you want a big portion of the water removed. We have other standards. Nitrate is a drinking water limit of 25 ppm. Nitrates can come from breakdown of algae, and that's related to this article, chlorine demand disappearing, chlorine reading. When certain organic material, particularly over winter, in poorly winterized pools, they open up as black, it's quite likely that certain types of bacteria have broken down twigs and leaves and other junk and liberated some nitrogen. And that sucks up huge amounts of chlorine in the process of shifting it over to a nitrate. The customer say, gee, I've shocked 3 times and I still get a 0 reading. Read this newsletter. And in the Alden Leeds website, listed on the back, I have many different newsletters online available. This happens to be the most popular one. The date on it is 2/06/207. I haven't had to publish one since this, because this has been hits the main nerve. Every year, there are plenty of pools out there that will suck up a lot of chlorine in the process of cleaning up, much more than normal. They are most likely cleaning up garbage. And when this type of nitrogen, organic nitrogen, reacts with chlorine, it doesn't give you a smoking gun the way that inorganic nitrogen gives you a smoking gun. And you know what the smoking gun would be? A chloramine. Certain nitrogens, inorganic nitrogens, will give you, then you shock it, you'll look and you'll see a high combined chlorine reading. Bingo, you're onto something. Now at least you know what you're dealing with, a combined chlorine. And then you could rid it with prescribed amounts of the oxy, for example, or prescribed amount of superchlorination. But if you keep getting 0 chlorine, it's pretty well assured that you don't have inorganic nitrogen, it's organic nitrogen. Organic nitrogen reacting with chlorine does not give you a testable anything. Hence the disappearing chlorine reading. Now there are possibly some other reasons for the disappearing chlorine, but that's the main one. So this nitrate level, it builds, and I've tested water plenty of times with a nitrate dip strip. Hopefully you have one for sale here. You got the?
Yes.
Yes, and I need to pick up a vial or 2 on my way out for a testing use. And I've seen them as high as 50 ppm. That exceeds also a drinking water standard. There's a danger to children called blue baby syndrome. 25 ppm is the legal limit of nitrogen. So that's a good reason to be able to say to someone, if you detect it, either you're going to spend tremendous amounts of money in shock. The world's record is about 200 ppm of chlorine to finally break through and show a reading. That's 20 times normal shock. It's not applied all at the same time. And in our article here, the conclusion on the 2nd page says, okay, so we kind of understand what's going on, but the remedy is still the same. You just double shock or maximum triple shock every few days until you break through. But because it's expensive, if there's still nitrate in the water, it's still technically unhealthy, better to drain and refill. I mention these because they become valid reasons to convince someone to change out their water. Good, solid reasons supportable, because we find historically that people want that $20 silver bullet, throw me in a chemical. They don't want to get rid of the water, even though you might be able to show 2 or 3 reasons to do so. It's the last thing most people want to do, is change out a lot of water. Could be because the new water coming in is poor quality. But that's in the case of calcium, in the case of nitrate, in the case of high stabilizer buildup from excessive use of trichlor, it is the only way out. And if you happen to have a couple of these, 3 of these reasons, that's the answer. I've told plenty of homeowners over the phone long distance, they didn't like what the dealer told them. The dealer got frustrated and said, here, call this guy. And I said, that's all you can do. You know, thanks for calling, have a nice day. You gotta get rid of that water. Now, along with this disappearing chlorine needs for a lot of shock, I have an article called Nitrification, How Green is Green. The EPA does not let us put multiple dosing on the label, multiple shock dosing. It says, add a bag or a gallon of liquid chlorine per 10,000 gallons, and oh, if that doesn't get the job done, essentially, do it again. Well, most of us in service, and if the EPA is listening, we certainly agree, we don't endorse this, but in service we know it's difficult to go according to that dose. We know from experience that many pools require 2, 3, 4 times that dose, and quickly. So most people in the trade have developed their own protocol. If you can't see the bottom of the deep end, you're at double shock. If you can't see the bottom of the shallow end, maybe you're at a triple shock. If you can't see a few inches in, who knows? But if you can't see a few inches in, I tend to think a good blind vacuuming is the first step, not just heaving in a lot of chemical. You don't know what kind of a layer is down there. If you have a sludge layer that you can get out manually, you really need to do that first, as unpleasant as it is. Chlorine, you'll waste a tremendous amount of chemical trying to decompose a sludge layer that you can filter out or vacuum out. Time is money. I think the performance demands it. You say, look, you could, because if you broom it, you can see a big mushrooming stuff. And you're not going to make that disappear with 3 or 4 times normal shock. It just doesn't work that way. Tremendous load in there. It's got to be vacuumed out. That would be equivalent to having a vacuum cleaner that's kind of clogged up and yet you're still vacuuming. It's just nothing's. It's not going to work. So we see routinely 30 to 50 ppm of shock needed in many startup pools that don't even have issues of huge nitrification or a lot of garbage in the pool. Chemtura Biolab claimed they had a lab, a test station, called the chlorine demand station, where they could take a water sample that had the super high need and kind of predict in advance by digesting that water sample how much shock. But the numbers were astounding. They're routinely reporting 25 or 50 pounds of cal hypo in a 30,000 gallon pool. Okay, well, what's the difference between knowing that you're still not going to put in that much at one time? You'll raise the pH too high, you'll milk up the water, you'll start bleaching liners, and nobody does that. They go, even the fastest serviceman is not likely to use 25 or 50 pounds at a time. You know, I say that knowing that some do, but they're not doing it in a liner pool. So we cannot give you the best. We haven't advanced our testing skills and products to provide accuracy for these startup pool situations. Blind vacuuming, triple shock, big dose of the algicide. Again, even as strong as copper as it is, you don't want to use it where you have a lot of shock present. Quart or 2 of poly 60. These are legitimate, tried and proven techniques to get these pools up running quickly. I have had mustard algae. I like to say something positive about my recent experiences with copper algicide. I've had pools of 30,000 gallons, bright green, Kelly green, extremely advanced mustard. And I have a photo library that's unparalleled in the business. Because I've talked to my colleagues, I've collected hundreds of photos, a lot of them are the same things over and over again. But I now can see a certain pool, a bright green pool, as a good 2 quarts of copper algicide, full strength. And you know what, there was no chlorine in the system, but after the thing was cleaned up, there was no copper left over. Copper will, if there's algae to be killed, it will absorb the copper and leave the pool. And I was very, very impressed by that, because it's easy to chart that copper. You can catch it in the backwash and see it coming out. And of course, the copper test is good enough that if there was too high of a level, because you accidentally put in too much, you'd be able to see it in the pool. Now, I'm talking about a pool where you couldn't see bright green a foot in, and it took 2 quarts. I was live and learn. I wouldn't have, because the dosing on the label says maximum about a half a quart at a time. So that's four times the label dose. And it turned out to be the right dose. We are constricted by the EPA labels. It's for safety, it's for the majority of the situations that we encounter. Sometimes we make decisions to go beyond that. The subject matter for minerals and algae do intermingle when we're talking about discolored pools. There are times when there are both algae and minerals in the water. If they're both detected, the safe route is to treat for the minerals first. Most people don't. They're trying to get it cleared up so they can see what they've got. But the safe route is to treat the minerals first. You really cannot do both procedures at the same time. If you have a lot of minerals present, and you have a lot of algae present, and you treat the algae first, you're going to make the minerals worse, because the algae treatment's going to inevitably require a lot of shock. There's no way the minerals will stand there and not take that. They're going to react, and you get some staining. Now, you know the expression, the canary in the coal mine. The most severe sensitive pools for minerals are the fiberglass pools. Historically, all over the country. If there's any mineral there, fiberglass is going to start to pick it up, and for the most part, brown. So certainly for those pools, if there are any that you're dealing with, you want to treat the minerals first before shocking. It's a great instinct to just open a pool and shock it and not want to check for the minerals. So you look at the pool's history. I think we're coming pretty much to quarter to 12, so I don't want to go too much longer, but I've done a lot of talking. I cover a lot of things in like pieces of the puzzle. Are there any particular pool problems or questions that at this point anybody would like to mention or comment on, or ask anything more of what I said?
Would minerals be considered also the phosphates in the pool?
Phosphates, okay. Phosphates are a great subject. Most of us begrudgingly agree that phosphate removal is a good thing, but not the first thing.
Okay.
It's an expensive treatment. If you feel, and phosphates are going to come from fertilizer drift, they'll come from overhanging stuff being released, they could come from the water source. Municipalities are allowed to use a chemical called zinc orthophosphate to treat their plumbing. A little bit of phosphate, the drinking water standard is really high. I mean, phosphates are in dairy creamers, soft drinks. It's really benign. We have this recent concern of them in pools at an excessive level. We think, most of my colleagues agree, that natural chemistry's push of phosphate removal is suddenly the #1 concern is dramatically overblown. But that's what they sell. So much of their product line relates to that. I have analyzed many water samples, hundreds were problem pools. Nobody's gonna send me a water sample of something that's in good shape, just when there's a problem. I've seen algae tough to solve with phosphate and without in the water, detectable. I've seen pools running great with phosphate and without. Now, statistically, I can't mandate its use unless your checklist of techniques have failed to solve a problem. And the grave concern that natural chemistry, I believe, shares that algae wish to grow quickly if there's phosphate in the water.